Good afternoon. Today we are going to talk about the sustainable building of a cement company. Our group are Carlos Emilio Angarita, Cristian Camilo Rojas, Jorliet Daniela González, Juan Fernando Vega, and Karen Castaño. Okay, the project select for this work was the Argos Center for Cement and Concrete Innovation, located in the city of Medellin within in the EAFIT University. It was designed by the architect Lorenzo Castro, and his idea was to create a flexible building that would adapt aesthetically to the university's infrastructure and, of course, be environmentally friendly. It has a 6 floors, 12 laboratories, and 60 workstations. The investment made by the private entity was 25,000 million of pesos, and additionally, it allocated 5,000 million of pesos for the endowment of laboratories and the purchase of implements. For this project, an alliance was created between the concrete company and NEAFIT to achieve several objectives. One of them was to celebrate 55 anniversary of the university, and on the other hand, a great investment of time and design and cost was made for that facades would represent that the cave concept that looking for and his was science outside. These two facades have a large format and are as follows. The insert facade has architectural elements in the form of a blade that allude the books and knowledge, and the western facade is formed by the cones that represent researchers and their eyes looking through a microscope to provide solutions. In accordance with the urban planning, the project presents a topography defined by the different folds of the ground that connect with the different entrance to the levels of the project. In this interior, in most of the floors, we are only laboratories and integral gardens, except for the first floor, which has a atrium and an auditorium with a capacity of 60 people, and also it last one in the point of reference and entrance to a well-known staircase balcony, which is an ascending road through the showcases, corridors, and interior gardens.
Okay, now to continue, we will present the theory certification. Then the first environmental certification used for the project is LED, which means Leadership in Energy and Environmental Design, a program founded in 1993 and adopted in more than 40 countries around the world. This program has 4 levels: basic certified, silver, gold, and platinum. Those certifications take into account 6 main categories. The first one is sustainable sites, water efficiency, energy and atmosphere, energy, materials and resources, indoor environmental quality, and finally, innovation in design. In addition, this rating depends on the type of construction being analyzed. In this case, is use the building design plus construction with the new construction item, taking into account that this structure was constructed in 2015. So that with the information recollect about the project and the tables are available in the reference guide for building design and construction, the result was 107. However, in November of 2016, the project received 64. That difference could be because of the information available on internet to answer the certification points that we use to basically uh, take our certification.
Okay, the next certification using the present ESI is the WHEEL certification, known as a dynamic scoring system for building and communities that allows identifying, measure, and monitoring the characteristic of the space in order to measure the impact on the health and well-being of their occupants. Its implementation in project lies in the definition of health and a state to complete physical, mental, and social well-being, and not simple as the absence of design, seeking and healthy life of the well-being. The concept hinged by the well construction standards for the scoring are air, weather, feeding, illumination, movement, thermal comfort, sounds, materials, mind, and community. In the performance verification of the performance testing process, they are based on the previous concepts and are evaluated by mean of text. Some of these are direct reading and others are sent to laboratory. In addition to the visual inspection in this project. Some examples for the wheel performance verification tests are the air quality test, the water quality test, the lighting test, and the acoustics test. Mm, In this case, the final score is based on the predictions and the total optimization achieved, where is the expect that all the predictions will be met to achieve the hour of wheel certification with higher levels in this. Once prediction have been chosen, they follow formulas are applied according to whether they passed or failed.
Okay, the last one certification is BREEAM. BREEAM is a sustainable certification for buildings, in this case, existing buildings. This certification takes into account 8 categories of evaluation, being the following: governance, local economy, environmental condition, social welfare, resource and energy, land use and ecology, transportation of movement, and innovation. For this project, the Argos Center for Innovation was rated based on these categories and obtained a score of 74 of points out of 100, which took into account factors such as the participation of the university community in the governance category, involvement in the creation of knowledge and employment in the local economy category, the reduction in energy consumption through natural lighting and low energy lighting for the environmental condition category, and reduction in the consumption of drinking water using rainwater systems for the category with the highest weight, the resources and energy category.
So to continue analyzing applications that will be taken into account in the project to achieve this certification and the synergies between them, it is taken point by point that, first, energy and atmosphere. Taking into account the design with which the building was built, it can be said that the project seeks to optimize energy performance as much as possible, since the architecture of this is based on large windows that allow the passage of the sunlight. That is, saving are made in energy consumption for the lighting of the space. This during the daylight hours, managing to reduce energy use by 4% in relation to the energy use that usually occurs in buildings of this capacity. In addition, the building makes use of friendly transport and also promotes the fauna and flora in the facilities, thus giving benefits to the atmosphere. Second, localization, and transfer. Taking into account the above and evaluating the building in question, we can say that it meets some of the requirements to approve them, since it actively promotes environmental awareness, offering good quality conditions such as showers and parks for people who decide to use low pollution transport. In addition, this has an accessible location because it's located in the Airfield University, thus allowing hundreds of people to observe different investigations from the inside and outside of the place. Third, water efficiency. The building has a rainwater system of the roof of the building, which allows the collection of the water for non-potable water use, such as for the irrigation of vegetation, internal use of sanitary system, which will allow 72% reduction in water consumption. 4. Materials and resource. The project has precast high-stretch concrete for colored pavements, colored permeable concrete for industrial floors, and cell-compacting concrete, a compendium of materials that promote the level of innovation invested in the project, where 63% of the products are of age value for Argos. In addition, the project will promote the biodiversity of plant species and reduce the consumption of drinking water by irrigation of vegetables, being covered by plants for an area for 45%, which will reduce the thermal sensation of the building. And finally, air pollution. The project has large areas of balconies, floor-to-ceiling vanes, and natural of 45% covered with vegetation, implementing sustainable strategies that allow oxygenation of the project environment, directed benefiting the more than the 60 feet and mobile workers on the place.
Okay, in this table we can see the synergy or comparative table where it was based taking into account 5 factors: energy and atmosphere, location and transportation, water efficiency, materials and resources, and air pollution. From each of the factors, some sub-factors were defined, of which were evaluated according to the scoring standard of each one. In the previous synergy, there is different activities are compared taking into account the aspect that they can be implemented in the project, where this emphatically shows a viable path for the certification of will, bring, and leadership in energy and environmental design. This can demonstrating sustainable design parameters that are very well relate between the three proposed certification. This can generating an impact on the social, environmental, economic, and investigative aspect. And in addition, this project demonstrates how to create a gap between the constructions and the environmental fields can be mediated, creating a innovative solution for the cement industry.
To finish this presentation, we can conclude that this project meets the different objectives of its certification presented below. Use. In order to this, we can say that the project is sustainable, since it is a project that implements the saving of energy and drinking water, in addition to promoting the use of the transport that don't produce exaggerated amounts of CO2. And to finish, the building protects the ecosystem, this by promoting biodiversity and planting vegetation in the building, which will reflected in the certification that we have been used. Also, the project is still lacking in environmental awareness, since renewable energy, such as panels, are not yet used. It is also important to mention that it doesn't promote the use of electric cars and doesn't have roads that avoid the excessive use of pollution full vehicles. Thank you.